Hyun Kim, CEO and co-founder of Superb AI. Welcome to the Data Exchange podcast.
Thank you, Ben. It's a pleasure to be here.
And I looked through your background in preparation for this conversation, and you have a great background spanning ML, robotics, um, academia, as well as industrial research. So obviously, the first question that comes to mind is, given your background in robotics, reinforcement learning, machine learning, when it came down to building a company, why did you choose to focus on data rather than, people regard models as kind of the hot, sexy topics, right? So,
got it. I guess before answering that question, let's go back to like very early on before I got into robotics and everything. I think it's going to be new to you that I started my academic interest or research endeavor in genetics.
oh,
So I majored in biomedical engineering and electrical engineering. So initially I was interested in genetics, gene editing, using E. coli bacteria as yeast to produce these synthetic materials, right? And I spent around 2 years in a wet lab, pipetting a lot of PCRs, things like that. And the number one reason that it got frustrated was it's really hard to debug these wet lab experiments. So then I looked around other research labs, and I think naturally I got interested in automating things. There were a lot of manual, repetitive pipetting works and stuff like that. So then I looked into automating all of these processes, and that's how I got into robotics. I wanted to have robots repeat all these experiments and so on. Yeah, so I got into robotics, and I also got into medical imaging. So basically using deep learning to analyze like brain MRI to
so this
detect
was
tumors
already,
and stuff like that.
so by the
Yeah.
time you got into it, deep learning was already the thing.
So the time when I got into medical imaging, it was around 2014. So back then, I think random forest or Connect was just coming out. A lot of papers were on random forest algorithms on like Connect data, and then there were some like deep learning folks out there writing papers on how computer vision, convnets work so well. So I think it was right around that interesting time for deep learning when I got interested in this computer vision. So so this was when I went to my grad school for my PhD. So I went to my PhD in 2015, and I joined a lab that studied robotics and RL. So my research focus was basically having robots play around with objects and learning to manipulate these objects using trial and error, basically deep learning / RL. And about 1 year into my PhD, I took a leave. And what happened then was in Korea, there was the AlphaGo event.
Oh
Lisa
yeah,
Dole
massive.
played AlphaGo. Yep, in I think it was March 2016. And then to everyone's surprise, at least everyone in Korea, to surprise, AlphaGo won, and all these companies like Samsung, LG, all these companies, they were very surprised, and they quickly decided to invest heavily in AI research. So that's when I got an offer from one of the research labs in Korea. So I took a leave, went back to Korea, and that was the first time I had exposure to corporate research lab. So out of academia into corporate research lab, experiencing more practical ML
But
applications.
but your timing was perfect because you're studying RL and then AlphaGo.
Yeah. So I was actually betting on the fact that AlphaGo will beat Lisa Go. but like all of my friends in Korea, they were against me. And I was like, yeah, I told you. Yeah. So yeah, when I joined the corporate research lab, I worked on things like self-driving, like smart speakers, chatbots,
So
game
self-driving,
AI.
so
Yeah.
self-driving. Now you're starting to really you're starting to realize the importance of labeled data then, right?
Yeah. So label data for self-driving, also for I worked a little bit on StarCraft AI. So I had to gather all of these like replay data, think about how to label the replay data, and all of these things. So, it came to me that I was spending too much time on basically the data and not the model. So collecting data, not labeling it myself, but outsourcing the labeling work, and reviewing, auditing, all of that just took too much time. And as a researcher, research engineer, I should be focusing more on models, right? But I found myself, my colleagues, and pretty much everyone that I knew in the industry was just spending too much time on data. So that's why I thought, this is a big enough problem. This is a problem that I'm experiencing, the one that I'm interested in solving, and that will have big enough impact in the world. So that's how I got into data instead of models.
And it sounds like also a theme in your work is you're all about making people more productive and efficient and automating repetitive tasks. So it makes a lot of sense. So Yun, when it comes to data labeling for computer vision, for our listeners who are not familiar that much with computer vision, so if you were to lay out what are the key parts of a good data labeling or data management solution for computer vision? So what are the key features and components?
Mm-hmm. For a good computer vision data labeling / management tool,
Yeah.
you're saying. Got it. There are a couple of things. One is data pipelining is a big key point. So companies and teams, they store data like all over the place. Sometimes they have it on their local hard drive. Sometimes they have it on cloud. And oftentimes it's all spread across different folders and file structures and whatever. So being able to connect with all of these data sources, and combining it into one central warehouse is what I call data pipeline. First half of data pipeline. The second half of data pipeline is feeding all of those data once it's labeled, feeding all of those into training environments. So it could be some GPU servers, could be your local desktop, could be I don't know, some cloud services, I don't know, AWS or GCP.
A way for the machine learning engineer to query the warehouse
Yep,
and get the data
yep,
that they want. By the way, you when you use the word warehouse, of course, in the structured data
yep.
world, there's the data warehouse. So,
Yep,
are there
it's different.
is there the equivalent of this in computer vision?
Um, Not so much yet, I don't think. It's much earlier than structured data in terms of maturity. So, yeah,
But you have the same you would have the same requirements, right? Like for example, in structured data, you have to have access control. You want to make
yep,
sure that only the people who are allowed to see these images can see it, right?
yep. So that's the second part, access control. So the thing about labeling training data, there are a lot of stakeholders involved. So, for example, there's the crowdsourced / in-house data labelers. There are the data QA QC auditors. There are the project managers that train and review the labeling team. There's also the ML engineers and researchers that basically consume the label data. So given that, it's very important to control who gets access to what, right? So having access control, having for example, the labelers get only access to the small subset of data that they're assigned to. It's very important to do that for data privacy, data security and all that. So yeah.
And I imagine based on the personas you listed, you also want a data labeling / data management solution where they can all work together, collaborate.
Yes. Yep. So collaboration is also a big piece. So initially, so when I say initially, it was, I mean, like the first 6 months of starting the company. Our one of our first customers was LG Electronics, and what they did was they basically sent us or any other labeling company like a hard drive with the data. So it's very difficult to give or receive feedback on the data labeling task, right? So having a
So
UI where
literally they send a hard drive comes back with the data label.
yeah
Wow.
hard to believe, but yeah, they actually did that. So it's very important to have a web UI where multiple people can come in, like how we have Google Doc, we leave comments and replies and resolve issues. So things like that. It helps the labeling project managing a lot. So that kind of collaboration is a big piece. Also, a key aspect of data management platform is automation, and it's one that we try to differentiate ourselves from others. So, like you mentioned earlier, my whole career is centered around automating and productivity and all that. So I think data labeling and management itself has a lot of manual, repetitive tasks involved. Obviously, data labeling is a big piece. And on top of data labeling, there's also things like data auditing, review, QA/QCing, and even for engineers trying to visualize their data set in a useful fashion. There's a lot of like manual one-off coding. So we're trying to get rid of all that. So we can get into the details later, but we do have a lot of in-house built algorithms that can assist all of these small chunks of works.
So it sounds like your platform will help across the entire pipeline of data management and data labeling, right? So including the QA/QC, which is, I imagine, quite important, right? So and then the
Yep.
ability. So I imagine you also have the ability to let me know that hey, this data. If I'm a machine learning engineer, hey, this data has already been QA'd, right? So there's some kind of there's some kind of a status on the data.
Sure. Yep. And also, what consists what makes a good data set is, there are two aspects. So one is, are the labels correct? So like, did you label a person as a person instead of a dog, right? So that's label accuracy. So that's one aspect of QA/QCing. The other aspect is actually on the raw data itself. So let's say you have a million images for self-driving. Are your data set, are your images all from the same street at the same time, right? You need to have a variety of images. You want night and day, sunny, rainy, snowy, highway, city streets, all that. So being able to visualize the distribution of your raw data and whether it's all clustered in one small niche data set, that's very important. So we focus on both aspects. So being able to tell our users whether the labels are correct and whether the raw images are well distributed. That's very key component to our QA/QC.
So quick question before we go deeper into label data. A few years ago, there was a lot of hype around synthetic data, and I'm a bit of a skeptic. So I want to get your take. So what is the truth about synthetic data in industry as opposed to the headline articles that we write? Is it at the point where you can actually just forget about data labeling?
So the first time that I was exposed to synthetic data was actually during my PhD. So, like I mentioned earlier, I try to have robots, play with objects and learn to manipulate them. So there were a lot of, trial and error, leading to robots, just wear and tear. So I wanted to play around with, synthetic data using simulations and all that. And the key issue was, is simulated data representative of the real world? And I think in robotics it wasn't too bad, but I think for computer vision, pixel level, accuracy or the pixel level photorealism, it's really hard to achieve. And so that I'm a skeptic, but recently I heard that there have been a lot of good research coming out on photorealistic style transfers that transfer synthetic image to a real like image. So I think there are some promising recent works, but we'll see how things turn out.
So how would you characterize, where would you plug in synthetic data right now in a machine learning pipeline or application? Is it only for maybe testing the robustness of the model, or where would you be comfortable using synthetic data?
Good question. I think it's safer to use it as, like you mentioned, a test data, see how the model performs on edge cases that's hard to generate naturally. For example, for self-driving, if you can come up with synthetic images of car crash, car accidents, it could be very, very valuable in evaluating the model safety and all that. Um, if the synthetic images are realistic enough, we could try mixing those into the training data as well. But I think we should be very careful with that, especially for applications like self-driving, where safety is the number one issue. Yeah, but we'll see.
So
I think
most
I
of
think I think the the technological breakthrough, especially in deep learning, it has always been faster than I've expected. So I think there might be some breakthrough in the coming months or years.
so Yun, most of the users of Superb AI, they're the main way they use the data is for ML, right? So machine learning,
Yep.
correct?
Yep.
So one of the things, so I've been thinking a little bit more about ML ops and ML monitoring. So one of the things that is clear to people who use ML is that once you train a model and deploy it, it doesn't mean, I mean, your job is only beginning in many ways, right? Because the model,
Yep.
the real world data may be different from your training data. There might be drift, there might be changes in the world, and so on and so forth. There might be adversaries. So there are many reasons why a model will degrade in quality over time. So
Yep.
how does that impact your training data, and how do you plug into the whole ML ops pipeline of retraining and monitoring and so on?
Got it. So the core of all of that is basically closing the loop. So you don't want to go from raw data, label data, trained model, deployed model, and finish there. You want to have the deployed model somehow loop back to data collection and labeling, right? So that's the only way to keep the model from like divulging to or degrading its performance. So I mentioned earlier, a big aspect or big feature of our platform is automation of data labeling. So we provide two different ways to automate data labeling. One is we give our users our core heavily trained backend model that they can use to adapt to their data to label their data, right? This is something called auto labeling. We can go into a bit more detail later, but that's one way. The other way is if the user has already a trained and deployed model, we let the users use their model to label label data on our platform using SDKs and APIs. And some clients they have things like uncertainty or confidence metrics that come out of their models, and using that they can use that to basically evaluate how their model is performing on new data, and basically select the subset of new data that their model is not very confident on. So this is active learning, so the users can focus on more valuable data instead of labeling every single image. And if the user don't have such a sophisticated model, we do provide it on our platform. So we do measure the difficulty of the images or the uncertainty of certain model outputs to help the users hone in on the more valuable subset of data.
I see. So basically, what you're able to do is if I deploy my model and my model starts encountering data that seems to be quite different from the training data, you will recognize that, and then you will make sure the labelers get to that data quickly.
Yep. So what we'll do is we'll basically score, our AI will score images based on how difficult it was to label that image. And that score is based on something called uncertainty metric. So it's similar to confidence metric. So based on that, we score the images and let the users know which images are difficult to the AI. So oftentimes those are the ones that have very dense themes, so a lot of objects to label, or a lot of occlusions, or truncations, or rare object classes, and so on and so forth.
So what do you mean by auto labeling?
So auto labeling is a name for our automated data labeling feature. So it's basically we'll give the users a pre-trained model that they can use to label their data. And in addition to auto label, we provide what's called custom auto label. What that does is, if say the user has a very niche data set, I don't know, maybe from manufacturing pipeline, could be, I don't know, a camera in a unique viewpoint and angle. So they want to have our model be fine-tuned on their data. So what the users will do is they'll initially they'll manually label maybe a few hundred images and use that labeled image to fine tune our model in just a few clicks. So they'll hit train button, they'll wait around 30 minutes to an hour, and we'll spit out a model that's fine tuned to the client's data. And from that point on, they can use the new updated model to label the next batch of their data set.
So this auto labeling does that literally mean once the auto labeling tool is tuned, you don't need any more labelers?
No, I think labelers or human input will always be needed. So what happens is, after the model is tuned, the user will run auto label on their data, will output the labels plus all of these difficulty / uncertainty metrics on how our model performed. And based on that, the user will come in, filter out the difficult images, and focus on reviewing and editing the output of the model for those select set of images.
So in terms of data management for computer vision, Yoon, as you mentioned earlier, we're still in the early days, but so in the MLOps situation, right? So if something goes wrong, you want to do root cause analysis, maybe, and maybe you realize that this model was trained using this data, and then you realize that some images were mislabeled.
Mhm.
So how do you do that if the images are just stored in a file system, or how do you
Mhm.
navigate through a huge collection of images? So what is data management in computer vision?
So I mentioned this earlier. We do provide um, data analytics for both the metadata, the labels, and also for the raw images. So, so let's see. For the metadata, for the labels, you need to be able to quickly spot human errors within your labeled data set. And if you have a huge data set, it's impossible to do it manually. You can't, go through every single image, right? Um, so put it in a very naive or easy terms. What we do is we have a AI model go through the data set and try to pinpoint where the model thinks we have a human error. It's not perfect, obviously, but it can help a lot in reducing the number of errors in the data set in the labels. That's one thing we do. The other thing is visualizing and trying to figure out the distribution of the raw data, whether we cover all of the edge cases, whether we have for example, for self-driving, whether we have night and day covered, do we have different streets covered, and we do that by see if I can explain it in plain terms. We try to describe the images in a few numbers. So
Right.
basically, reduce the number of dimensions in the data, right? And using that, we try to visualize it in a 2D plane where each data sits, right? And if all of the images are clustered in one area, we can say the data set is not very well distributed, or if it's biased towards one or two cases, it's not very well distributed. So you want to go back and do a better job in collecting a more diverse data set.
So in the structured data world, so a couple of things that people do with data. One
Mhm.
is they do data preparation, data wrangling kind of thing.
Mhm. Yep.
I'm not sure if you folks in computer vision do that. The other thing they do is they may run simple queries, to check their
Mhm.
data. So are
Mhm.
are are there equivalent tools for these two things in computer vision?
Yeah. So simplest thing that users do on our platform is basically checking the frequency of each object class within the data set. So let's say you're trying to detect cats and dogs. Do you have 99 dogs and one cat, or is it 50-50? Right.
Right.
That's the first thing that you need to do to see if your data is well distributed. And if it's not, you want to go back and collect more images of cats, right?
Right. Yeah, interesting. Let's see. So how do you, so I guess this is another thing I'm trying to map for our listeners, some things that are starting to come out in structured data. I don't know if this particular part of the structured data ML stack is in computer vision. So in structured data now, there's a whole bunch of solutions and even startups that are offering what people call feature stores.
Yep.
So, is there something similar in computer vision where if you if you are able to process an image in a certain way, then I can learn from what you did, and you know what I mean?
Yep. Um, it's something that we're investing in a little bit,
Okay.
not a whole lot, but I think like you mentioned, it's much more popular in structured data. But I think the need for a feature store will come out in the future in unstructured data domain, but not so much yet.
By the way, we keep talking about computer vision and we keep using the word image, but really
Yeah,
most of
yeah,
the use cases are video, right?
yeah.
So
That's true.
so what's the main difference that people should know between images and video when it comes to labeling and data management?
Let's see. So labeling, the I guess the only difference between image and video is in video you want to track objects throughout the video.
Yeah, like
So
over time
yeah,
almost. Right?
yep, over time. So in images, you have, basically two values. So X and Y, the coordinate within the images. In videos, you have a third coordinate, which is time. So you want to be able to track object throughout time. And if, for example, if let's say a person moves in space throughout the video, so we track that person. And then in the middle of the video, let's say a car goes in front of the person. So the person gets occluded.
Right.
So after the car passes by, you want to be able to redetect the person and be able to identify the person as the same person that you identified in the beginning. So we want to, put the tracking ID consistently throughout the video. So that's very important for video labeling. For video management, I think
Volume is going to be massive, right?
oh yeah. So I was gonna mention volume. So it's important to decide on the frame rate. So let's say your original video is 30 frames per second. You don't want to store all 30 frames or label all 30 frames. It's not going to be very valuable. So you want to be able to, depending on the application, pick out the right frame rate to store and label data. So if it's really, like a high precision type of thing, that you want to have high frame rate. But if it's not, then maybe 1 frame per second could be much more than enough. So yeah, it depends on the application, but that's very important to save not just the storage but your labeling time. Because that's very expensive.
By the way, the other thing about computer vision is the data collection sensor, the camera, is
Mhm.
also subject to all sorts of challenges. It could get smudged, it could get
Mm,
dislodged, right? So there's a lot of things that can happen to the uh, if it's an application that relies on that assumes the cameras are positioned perfectly, right?
mhm.
So what have you encountered? Are you guys trying to build solutions to get around some of these real world problems with cameras?
It's not something that we focus on, but when our customers are having problems, we do give them our, based on our experience, we do give them some tips to help them navigate. For example, a self-driving company that's interested in liberating their LiDAR sensor with their camera sensor. Uh, we give them, we do have some experience outside of our company. We do have some experience, so we give them some tips, but not as a product or as a company.
So in terms of data management, data ops, and data labeling for computer vision, what are some things that you as a company, Superb AI, but also just the broader community, what are some of the big uh, things that are around the corner that might happen in the next 1 to 2 years?
Okay. Good question. So I think a few years back, I saw a lot of these end-to-end solutions. So meaning one company or one product that does, data labeling, model training, model deployment, all of that at the same time. I think the that's not going to be. So I think now I'm seeing a lot of companies that are focusing on just one aspect of the whole ML ops data ops pipeline. I think that speaks to the fact that the ML ops industry is just getting really big. It's just getting too big for one company to cover everything. So we're seeing, company that focus on just data versioning or focusing on data model training or model deployment or data governance or like you mentioned, feature store. All of these are used to be a small piece of the puzzle, but now it's not so small anymore. So we're gonna see a lot of companies or a lot of fragmentation in the industry, I think.
But on the other hand, you guys are very wisely providing customers with a more tightly integrated solution, right?
Yeah. So I think the key will be, key to success will be, being able to just, kill it in the area of that the company is focusing on. For us, it's going to be data management and labeling. And also important is collaborating with all of these adjacent solutions. So for us, we have the data. Our clients want to do model training when they have the data. So we want to be able to partner up with model training companies and be able to integrate our products together so that users can have more seamless experience, for example. Or we want to partner up with data collection agencies or data storage, cloud storage guys to be able to integrate with all of those. So I think that's going to be key in how the industry spans out, key to success.
But you are able to help me across the board as far as data management. So you handle versioning, right? So governance, privacy, and so on and so forth, right?
Yep. I mean, we do have some aspect of data versioning, some aspect of data governance, user management, and all that. But there are companies that focus entirely on, for example, model training, right?
Yeah. That makes sense.
And yeah.
But the fewer companies that I have to work with to stitch together an end-to-end pipeline, the happier I will be, right?
Yeah.
Yeah. So if you can handle the middle part, which is all of the data, I mean, that's a win, right? So
Yep. So we also partner up with a lot of data labeling companies. I think data labeling industry is much more mature than the entire MLOps data ops industry. So they are consolidated around a few major players. So we partner up with those guys, have our platform be a warehouse for data. And whenever new data labeling needs come up, we'll partner up with these guys and work together to provide a labeled data set.
yeah, interesting. Yeah, consolidation. So while you're here, I wanted to take advantage of the fact that you've worked in many areas and that I'm interested in and our audience is interested in. So I want to get your quick take on a few of these topics. So the first is reinforcement learning. How practical is it? And are you starting to hear more and more actual industrial applications of it?
Yeah. So, my initial exposure to RL was in robotics, but since I'm currently in data management, data labeling space, I see some recent works in RL in application to data labeling, right? And I think it's very interesting. So there are a couple of applications. One is using RL to evaluate the labelers task, right? So how it works is, RL is basically state, action, reward. So state is the current state of the world that you're seeing. Action is the action you make, and reward is the amount of reward you get by doing that action in that state. So that's RL, and it just so using that to evaluate labeler, how it works is the state will be the current state of the annotation task. So let's say the person is segmenting an object, an image using a polygon segmentation. So you basically have to click around the edge of the object. And let's say the action is each click where the user clicks in the image. And the reward would be calculated based on how accurate that click was in comparison to a ground truth polygon segmentation that you already have. So based on that, you can evaluate the users and model the users, basically how well the user performs data labeling. Right? That's one application. Another one is a more higher level, so more labeling project management / configuration. So what that does is using RL to distribute or assign labeling tasks to users. So it will learn to assign the right image to the right person. So the RL will, learn to basically, in plain terms, user A does, this type of image role. So I'll give user A all of these, or something like user B likes
It's like
to.
a
Yeah,
bandit
yeah,
algorithm
yeah,
for labor.
yeah, yeah,
Yeah,
yeah,
yeah.
yeah, 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 yeah. So RL and Bandit, they have a lot of things in common. So
So
yeah.
so these things that you're describing, how close are they to being practical enough that you yourself would consider?
So we're looking into it. We are not yet, investing a lot in RL research, but we're keeping a close eye on the whole RL application to data labeling management.
By the way, the last time we spoke, you spoke admiringly of what Tesla has done in terms of their data platform, right? In terms
Yeah,
of their
yeah.
data, in terms of their data platform. So, for our audience, what are some of the things that you like about what they've done in their data platform?
Um, Good question. So I saw Andre Karpathy's talk. So Andre is the head of AI at Tesla.
Yeah.
Um, and basically what they do is, they have all these fleets of cars around the world. They see the world, they collect the images, send it to Tesla servers. And within Tesla servers, they have all sorts of models to uh, annotate the images or videos. And after that, the model will also pick out, edge cases or the cases where the model's not very confident about.
So
And
this is their version of what you referred to earlier as
right,
auto labeling.
right. So, and then they'll pick out the small subset of images that the model doesn't perform very well on. They'll send it to their in-house team of labelers, and they'll add those labeled data to their central database, right?
But the key, you
So,
said, I think in our last conversation, the key is they're doing this at massive scale.
oh yeah, they're doing a massive scale, and I think that's one of their strongest competitive edges. And as a company, it's for AI, we want our clients to be able to build something like that using our platform. So that's where we plug into their ML ops data ops pipeline.
And then Yoon also, I guess, as you were describing that, I guess one of the holy grails in this space is not only to be able to do it at scale, but to be able to, once you detect a weak spot, to be able
Yep,
to turn around and fix that weak spot right away, right? So in terms of, for
yep,
example, if your model has not seen this kind of labeled data before, then you better be able to close the loop quickly, right?
yep. You want to be able to quickly get notified of model failures. You want your team to just go right in, edit or label the failure cases, and start the model right away, and ideally deploy the updated model version in as little time as possible.
Right. So, closing question is on this topic of self-supervision, which I'm starting to see more and more of.
Mhm.
Um, so first, define it in as close to layman's terms as possible. And then
Got it.
secondly, what are your thoughts about it in terms of practicality or near-term promise?
Got it. So layman's terms. So self-supervision is in essence basically I think it's a misnomer a little bit. Self-supervision doesn't mean like no label data. It just means you create the label data, but it's almost free. The labeling is free. So what we do is you do things like, for example, you have an image, you rotate it by 90 degrees, you put it into the model and have it try to um, correctly guess by what degree the image was rotated,
I
right?
see.
So the label is 90 degrees, right? But the way you obtain that label is free, right? You just rotate it 90 degrees. Or you do things like you just pick out two small patches of the same image and you try to have the model guess their relative position in the image, right? So you have I don't know, the eye region of a person's face and the mouth region, and you want to have the model pick out the eye over here, the mouth over here, right? So in essence, it's a way to have the model learn from the raw data by generating these pseudo labels or these low level labels for free, right? And I think it's very interesting, and we're actually investing a lot into this topic right now. um so how
So,
that's
so
helpful, yeah, yeah,
yeah, in your case, what's the practical application?
yeah, yeah. So when we provide all of these automation for data labeling, data auditing, and all that, we need to have our model trained on some data, right? And currently, we have a huge model that's trained on all collection of images, open source and our in-house made images, but all of them is what we call natural images. So it's like actual photographs that people took, and it's very it doesn't generalize well to, for example, satellite images, which have a completely different viewpoint,
Right.
or medical images which have completely different look and feel, right? So being able to use self-supervision to come up with these heavy backbone models that are trained on these domain specific data, like I mentioned, stuff. Satellite images is one, medical images is one, synthetic graphics is also one. And yeah, being able to have these core AI models using self-supervision and using that to, when the user comes up with, for example, satellite images, we'll fine tune our satellite image self-supervised model on the user's labeled data. By doing that, we can reduce the number of images that we require to train our model
I
on
see.
the user's data. Yeah.
I see. So the goal there is to make the auto labeling uh, part of your product even better.
Yeah, be able to generalize across more various data domains. Scalability. Yeah.
So why are people so excited about self supervision? Or maybe I'm just imagining imagining it, but I'm hearing more and more about it.
I think it's very promising. I think I don't want to sound arrogant or anything, but the concept is not very hard, right? I think anyone could have come up with this idea, but surprisingly, compared to the simplicity of the idea, it works very well in practice. So not having to like design the labeling specs and not having to label the data, which is very expensive, is I think that makes the topic itself very interesting. And being able to have the models learn these concepts bottoms up in self-supervised way is, I think, very exciting. And yeah, I'm keeping a close eye in the research space.
And by the way, the other topic that popped in my head as you were talking was GANs, generative
Oh yeah,
adversarial networks, which
yeah.
are used for generating synthetic data. But beyond that, is there anything else that you folks use it for?
So we don't use it. We don't use GANs in our product, but I do have background in GANs before starting the company.
Yeah.
So I mentioned very beginning of our talk. I worked on self-driving, StarCraft AI, all of that. I got fed up with the amount of time I had to spend on labeling data. So I looked at unsupervised learning, and at that time, GAN was the thing. So the work that I did, it's called Discogan, and it's the exactly same work as Cyclegan, which became much more popular from Berkeley.
From Alyosha Efros's group.
Yep,
Yeah.
yep. So, and I think so. The thing is, what we did was we took, for example, a male person's portrait image, try to generate a female version of that person, and by having the model do that back and forth, we had the model learn bottoms up what it means to be a male and what it means to be a female, right?
Interesting.
So being able to pick up those characteristics of maleness and femaleness from the raw images bottoms up, I think that was very interesting. And I think it somehow it reminded me of basically, I mean, self-supervision, self-supervised learning reminded me of the work that I did back then with Discogan. It's kind of similar how the model learns bottoms up.
Yeah, it's interesting. So yeah, so this has been great. I love the stuff you folks are doing. I just like actually the fact that more people are paying attention to data, because
Yeah.
it seems like models are interesting, but I don't know about you, but models are increasingly just, if I have the right data, you can have a better model than me. I'll still be,
Yeah, I think Andrew Yang's recent talk on data-centric AI I think it was very popular amongst practitioners, even our clients.
But obviously, all the headline articles and media coverage will continue with models, because who wants to write about, hey, I had that person has great data.
Yep.
Yeah. And with that, thank you, Yun.
Thank you so much, man.